In this video, I'm going to show you how you can use fundamental identities to simplify trig expressions. So, in the first example, I'm going to show you how you can simplify secant of angle x divided by tangent of angle x. So what we want to do is write secant and tangent in terms of sine and cosine. I know that secant of x is equivalent to 1 over cosine of x, so I'm going to replace secant with 1 over cosine x. I know that tangent of x is equivalent to sine of x divided by cosine of x. Here I'm left with the complex fraction. You can either multiply the top and the bottom of the complex fraction by cosine, or you can use a flip and multiply trick. I'm going to choose to multiply the top and the bottom by cosine. That way I can get rid of my complex fraction. So on top, I'm left with 1 because I crossed off my cosine x's. On the bottom, I cross off my cosine x, and I'm left with sine x. And I can also write 1 over sine x. I know that's the reciprocal of cosecant. So I know cosecant x can also be written as secant x divided by tan x. In my second example, I'm going to show you how to simplify tangent of x, so tangent of angle x, multiplied by cosine of angle x. I want to write everything out in terms of sine and cosine. Tangent I can write as sine x over cosine x. And cosine x, I'm just going to put a 1 under it so my fractions line up. Now I can simplify this. I can cross off my cosines, and I'm left with sine x. So tangent x times cosine x is equal to sine x. Now we're going to use our fundamental identities, and knowing that we can rearrange them in different ways to rewrite the Pythagorean identity in a couple different ways. So our Pythagorean identity, if you recall, is cosine squared x plus sine squared x is equal to 1. Now, if I take that equation and I divide everything, I can do whatever I want as long as I do it to both sides of the equation. I'm going to divide everything by cosine squared. Okay, so cosine squared divided by cosine squared, that's equal to 1. Sine squared over cosine squared. Remember, sine over cosine is tangent. So if I have sine squared over cosine squared, that's going to give me tangent squared. Whoops, this should be a plus. And the reciprocal of cosine is secant. So 1 over cosine squared would give me secant squared. So here's an alternative version of the Pythagorean identity. Now let's do that again, but this time let's divide everything by sine squared and see what happens. So if I have cosine squared x plus sine squared x is equal to 1. That's how we're going to start off. And then this time I'm going to divide everything by sine squared. Okay, when I take cosine squared divided by sine squared, cosine over sine, that identity is cotangent. And because it's squared, I'm going to have cotangent squared x plus sine squared over sine squared is equal to 1. And the reciprocal of sine is cosecant, so 1 over sine squared is cosecant squared. So here's a second version of the Pythagorean identity. Okay, so we have cosine squared x plus sine squared x is equal to 1. We have 1 plus tangent squared x is equal to secant squared x. And then we also have cotangent squared x plus 1 is equal to cosecant squared x. Let's use the Pythagorean identities to find all trig functions for the angle t. We're going to start off with cosine squared t plus sine squared t is equal to 1. Since I know cosine is my x-coordinate of the point on the circle where t sweeps out, there's my cosine. It's 12 over 13. So I'm going to replace cosine squared t with 12 over 13 squared. So I have 12 over 13 squared. And what I'm going to do is I'm going to solve for sine squared because I know that that's going to give me my y squared. And then I can square root both sides and find out what my y is. Once I know what my x and y coordinate values are, then I can find all the other trig functions. So I have sine squared t is equal to 1 if we finish up that equation. Okay, now 12 squared over 13 squared is going to be 144 over 169 plus sine squared t is equal to 1. Now I'm going to subtract 144 over 169 from both sides. So I have sine squared t is equal to 1 minus 144 over 169. If I make that 169 over 169, and I subtract 144 over 169, that gives me 25 over 169. So now I'm going to square root both sides. When I do that, I have to remember plus or minus. So sine of my angle is equal to plus or minus 5 over 13. Now, how do we decide what we're going to use, the plus or the minus? If you notice, this angle is in the fourth quadrant. And in the fourth quadrant, that y value should be negative. So I know that this should be minus 5 over 13 rather than plus 5 over 13. So I know that my cosine of the angle is 12 over 13. That's my x-coordinate. I know that my sine of the angle is minus 5 over 13. That's my y-coordinate. Now we can use our fundamental identities to find the rest of our trig functions. I know that secant of the angle is the reciprocal of cosine, so that's 13 over 12, is the reciprocal of sine. So that gives me minus 13 over 5. I know that tangent is the y-coordinate over the x-coordinate. So I'm going to take minus 5 over 13 over my x-coordinate, which is 12 over 13. And when I simplify that, I'm going to get minus 5/12. Whoops, I think this was supposed to be a 3 and I wrote it down wrong. There we go. Okay, and lastly, I know that cotangent of t is the reciprocal of tangent. Since tangent is minus 5 over 12, cotangent should be minus 12 over 5.